the use cases are another. What do you want to use it for? I mean, conversational search has been around as a research topic for a long while without AI. It's just being smart about the interface, and obscuring the sources of your information is a real challenge for a search engine, because that shifts the responsibility of what's being said from the reader to the generator.
But do you think if you add a requirement to actually do include the sources back, then...
Sure, that's the thing. No one will click on those links, though. So,
But perhaps it needs to align at least to the references that you do provide.
Yeah. So, I mean, obviously that should be a requirement, and some of the current tools actually do that, which is good. But if no one clicks on those links, it's easy to see how those might be very, very misleading, because the links might be, convincing, but not tell the full story.
I've been going back to your original example there. I think it's so funny, where you basically asked, was it ChatGPT?
Yes, I asked ChatGPT about myself, did a vanity search, and it gave me
How do you write it? Like,
who is Jussi Karlgren? And it gave me a very nice little CV, which was pretty much wrong in every detail. But
nothing right in it? Or?
Well, it was sort of right. It told a nice story about someone who'd worked in sort of my field, but it gave me a different affiliation and a different hometown, and then it told me I was dead. So I had to think a little bit about that, and I asked about my cause of death, and it couldn't supply it, unfortunately.
Did you tell it that it's wrong?
I tried, and it said, it was very apologetic, but it didn't take, because the next day I tried again, and it still was convinced I was dead. And this was surprisingly interesting. So I tried it in some other languages as well, and in some languages I'm dead, in some languages I'm not, which illustrates the bounds of what you can do with the chatbot.
Yes, the bounds that we have today. Do you think it will be a continuous bound, or do you think at some point soon, perhaps, it will be much more trustworthy?
Well, I'll have to say both yes and no to those, because the purpose of a language model is to provide language, not to provide facts. So and my prediction, which I'm optimistic about, since I tend to be an optimist about these things, is my prediction is that the language component of language models will be cleaner, so that it will be clearer that what they do is they provide language and that they don't provide knowledge. Because now people are playing with ChatGPT, using it as an oracle, and then being unreasonably pleased when it makes mistakes. Yeah. That includes me. It's very fun to trick it into saying things that are not true, but it's not been trained to say true things. It's been trained to say fluent things and coherent things, and it's like a well-read student who hasn't studied for the exam.
But given that it's been trained initially for a long time, and as you said before, language models, and especially these kind of large language models, has been around for a long time, but they haven't really interacted with a lot of people in the way that I guess we have now in a recent couple of months at least, and that they have been trained to simply produce a language, as you say, that is very nice from a linguistic and grammatical point of view, but has not been connected to the truth to a strong extent. Don't you think it's possible if now the reaction that we have been seeing on both ChatGPT and Google Bard, etc., don't you think that will be...
Well, it's a necessary thing, but I think it is important to separate the concerns. To be fluent and coherent is a different thing than being truthful and confident and reliable. And I think those should be addressed in different ways. Those are different training objectives as a technical term. You train something to be fluent and you train it to be truthful, and those are different practices. We can go to human learning and think about this,
right,
because we sort of acquire language without supervision. We just observe language being performed around us when we're kids, and then after a while we're able to express ourselves in that language. And but we're instructed using language about the state of the world and things that are on the other side of the hill that we can't see. And then we believe those things, and those we've been taught. So there are two different learning processes for us humans. And one of them uses language, the other one is acquiring language. And now we're conflating the two because as a side effect of having been exposed to a bunch of language, these things tend to be mostly truthful because it's easier to be truthful than to be untruthful.
And I think the topic of how to make these kind of large language models more truthful is super interesting. I'll add that to the list later because it will be fun to just speculate a bit about different ways to obtain that. But before we move into that, still, if you reason about this, if you take the average human, and perhaps a human that is not a scientist, but an average human, and you ask it a question about, what was the origin of the universe, or whatever question you can think of, do you think the average human is more truthful than the current version of ChatGPT?
Oh, wow. Well, the ChatGPT has been exposed to more factual material than your everyman, including your average scientist, because it's pretty much read everything there is to read. So there are more facts in the machine. They're not consistent with their, this is an incoherent database.
Yes.
So it needs to pick and choose from it, and it'll make mistakes, and it's not able to generalize in the way a human would. And also, it's not as well equipped as a human is to concede that it doesn't know about things.
So then back to the question. Do you think the current version is more truthful or less truthful than the average human?
That is a really cool question. If you'd posit a battery of bunch of questions about the state of the world and humanity and all kinds of things, I'll bet that the current language models would do pretty well on that test, but that humans would do better, depending a little bit on what those questions are, of course, because if they would touch upon the human experience, of course, the human would win. If there would be simple factoid things that are retrievable from the database of text, if you'd ask it to list all the capitals of all the countries in the world, a ChatGPT would probably do better than most people. Yeah. So it depends on how many points you get for each correct answer.
Yeah. And how abstract the question is.
How abstract and how much of a generalization you need and how much of an analogy But yeah, as long as it's either fact retrieval from facts that are explicitly mentioned in the text it's read, or it's a question of cobbling together something out of those facts, then ChatGPT will be a winner. But if there is a non-trivial amount of analogy work there, or if it touches heavily upon the lived experience of a human embodied person, it's a question who rigs the test. This is actually a good thing to think about as a quality assurance metric for future components and AI systems.
Awesome. With that, I'd like to say very welcome here, Jussi Karlgren.
Thank you for having me.
Very pleased to have you. I think we met a couple of times in various arenas. I'm not sure really from where, if it's from, you was at Spotify as well, and so was I, but I don't think at the same time, at least.
No, our years there didn't coincide, but
you're a very knowledgeable person, and I heard a lot about you from other people as well that respect you deeply, so it's a very strong pleasure to have you here today.
Thank you.
And also in your role as you're now working as a principal research scientist, right?
I think my title is principal AI scientist.
AI scientist.
AI scientist. I need to grow into the title because I only had it for about a week. But
but as a principal AI scientist at Silo AI or Silo AI, I guess it's Silo AI, right?
In English it would be Silo AI. I'm pretty sure. Yeah.
And you just released a new initiative, if that's a proper term, called Silo Gen, right?
Yes, we've launched a new initiative, which I am part of, called Silo Gen, which is an effort on our part to work more systematically on some of the things that we've all read about in the press lately.
Mm. So we get back to that very shortly, but it would be fun, I think, for the listeners to learn a bit more about your very extensive background. I mean, you've been at so many interesting companies. You founded Gavagai, you've been at Spotify, as I said, you've been at Recorded Future, and so many other places. And you're an avid board member as well and research advisor in so many different fields. So it's truly an extensive background you do have. But how would you describe yourself? Who is Jussi Karlgren?
Well, I like to think of myself primarily as a linguist because that's what my first undergrad degree was in, and it sort of stayed with me. And also, it's sort of a family business. My father was a linguist, and his uncles were linguists, and so forth. So I probably own more dictionaries than anyone else you've ever met. Not that I use them that much anymore because of things.
Yes.
But I've always been drawn towards the technical, and mathematical modeling is something I've always worked on. So I did my PhD in linguistics as well after a brief turn at doing human-computer interaction and dialogue models, even they're more language-oriented.
What year was this approximately?
So hang on, I got my PhD at the turn of the millennium after about 12 years of being a graduate student. I like to tell other graduate students I supervise that there's no need to be in a rush. It'll come to you eventually. Unfortunately, our system today tries to push people through without giving them space to breathe. But so I wasn't busy because I was working on sort of industrial projects all through my graduate students. I worked at what today is called RISE, then was called SIX for about 20 years, but I did visits to other places during those 20 years. And then I founded, together with Magnus Sahlgren from SIX, we founded Gavagai, and I worked...
That was in 2006?
Well, there are various ways of describing it. We first founded the company in 2008, and then we ran it as a side business for a couple of years. And 2010 was when we launched it properly, and then we were joined by other SIX colleagues. So there were 5 of us, former SIX employees working.
And SIX as in the Swedish Institute for Computer Science, right?
Yes, the Swedish Institute.
Wasn't that where we met at first?
Probably, so, because most of us have passed through those halls at some point here in Stockholm. It's one of those places where a lot of things have come about.
Yes. Cool. And you did your PhD, and you at the same time was working with SIX at that time.
Yes, I was at SIX during
and then
those years.
You and some colleagues from RISE or SIX founded.
That's when we formed Gavagai, a text analysis company, which I think we can fairly say was the first ever commercialized language model. It was a huge language model at the time. And this is probably something we might get back into, because I think today's language models, I'm exhilarated and impressed by what the field has managed to produce and launch. Yeah. But I'm also distressed by the wastefulness computationally and the, in some sense, bad engineering in those models. And we were very proud at Gavagai to have launched a model which was huge at the time, but was very parsimonious in terms of parameter space and memory footprint. So this was something we were very happy to. This was based on mathematical work by Pentti Kanerva, who formulated the sparse distributed memory model, and we applied it to language on his suggestion. He was a researcher at SIX at the time before he went back to California, and it worked swimmingly. The model was great. It learned terminological relations from text and was entirely incremental, and we were very proud of it. And we built some tools on top of it. Yeah.
Just go a bit deeper into what type of language model was it based on? Was it a recurrent neural network kind of model? Or
no, this was entirely built on kind of, this was based on sparse distributed memory. This predated recurrent neural networks. This was... So there's a whole tradition. I mean, neural networks were sort of blasted out of the water in the 80s, but they returned in the 90s. And Pentti's model of sparse distributed memory was formulated around those days and applied to a bunch of different computational problems. The main idea there was that representing stuff in vector spaces is wasteful by design. There's a lot of zeros in those matrices, and then there are all kinds of tricks to reduce the dimensionality and compact those models. And Penthe's insight was that this is stupid to build a wasteful model and then waste a lot of CPU time on compressing it, when actually the model we claim to be inspired by, our neural systems, patently do not work that way. So his approach, which was as implemented, called random indexing, was by design a fixed dimensional model. It sort of had a dimensional parsimonious approach built into the whole thing. So it was, the point of it was that it wasn't, it didn't need a compilation step. It was entirely incremental and online learning. And I still believe that some of those design principles, including the whole idea of random indexing, is the way to go.
So just elaborate a bit more how the random indexing worked. Is it more into the field of, what would we call it today, these kind of, I'm trying to figure out the name here now. If you want to find these kind of deduplication examples for vectors where you have, I'm struggling to find a name right now. Do you know, if you just elaborate a bit more?
So the point of random indexing is, let's see, there are several touch points to other branches of thought, but one of them, I mean, if you're a database guy, you'll know about sketches. So this is, in some sense, related to sketches.
Right.
It's also, but for those of you who are not, then let's put it this way. If you see something new come along, if you have a model and you put everything you see, every observation you make into a vector space, and then something you've never seen before comes along, all of a sudden out hops a zebra, and you've never seen zebras before, then typical vector space models are built in a way that this means you need to add a dimension, a new column in your matrix, or a new one at the end of your one-hot vector. Now, this is bad because this means that, well, your dimensionality changes with your experience. And this is not supported by evidence from the wet where we run. So instead, what you do in random indexing and related other models is that you generate a hash key randomly selected from your existing dimensionality and do it sparsely. So if you have a dimensionality of 1,000, you pick a few non-zero elements, and that gives you a pretty large representation space. And you can do it online without messing up your previous stuff. This means that stuff isn't exactly orthogonal, but orthogonal enough on average with everything else. And that'll give you a huge boost in processing.
So I guess this is similar to like mean hashing techniques.
It is a hashing technique, essentially,
yes. Awesome. And this is, I guess, also similar to like Bloom filters and you can now use...
Yes, those are non-random, of course, but in a way, yes. I mean, what you get is a... Oops, sorry, banging things around here. So what you get is a denser representation than you would with one-hot vectors, but you stay within the bounds of your dimensionality. And there are all kinds of mathematical proofs to show how well this works in theory, and in practice it works as well as those theories predict. So, so this is a very good, I would see this as a pretty good model for a perceptual layer for any kind of neural network model. So, but I don't need to evangelize for this. We'll come around to thinking more about those eventually in a few years' time when we work.
But you had random indexing. Was this basically on a word or token level?
This was a token level thing. We built a lexicon essentially, and we used that lexicon, then build some products on top of it at Gavagai. And Gavagai is still around. They still make those products. I'm happy to introduce anyone to the usefulness of topical clustering of customer feedback and such things. And of course, now there are more efficient ways or more elaborate ways of building word vectors or word embeddings than we did then. But we can confidently claim to be the first commercialized enormous, huge, large language model at the time. The design of that language model was late 90s, and it took us about 10 years to roll it out the doors as a product. And
what was the product of GABAGAI, by the way?
There were several along the years. We started out doing media monitoring, tracking what's being said out there about whatever you're interested in. But today, the main product is customer feedback or questionnaire processing. You ask open questions, and you want to figure out what are people annoyed or happy or surprised or disappointed about.
So from a set of replies from some questionnaires, you want to have some kind of semantic understanding of what they're talking about.
Topical clustering and sentiment analysis and such things to gain insights from what's being said by people out there.
Like topic modeling kind of process?
Topic modeling would be, that is a difficult term because it's used to mean a specific technology to do this sort of thing, a technology not employed by GABAGAI and actually not employed by anyone, I think, anymore because it was also quite wasteful, but in its own way. But yes, in the general sense, in the everyday language sense, topic modeling and then sentiment analysis on top of that to figure out, are the customers happy with our product? And if they're not, what are they unhappy about?
Awesome. I'd love to move more quickly into what you're working with these days, very recently in Silo AI as well. But you also worked at a place that I'm rather familiar with, which is Spotify as well. Can you just mention briefly what you worked with there?
Well, yeah, I spent about 4 years at Spotify, and that's a very exciting place to work with huge data flows and both in terms of content and in terms of audience interaction with that content. And I'd spent all of my career up to 2019 thinking that I would never have to deal with spoken language. And then I joined Spotify and started thinking about podcasts and realized that this is, hugely interesting. So I spent time thinking about how to provide the audience with the podcast they would like to be delighted by. So
let us try to understand or expand on that a bit. So Spotify had a big initiative on podcasts, and they need to know what podcasts to recommend to whom. And I guess in this case, you also need to understand what people are speaking about in podcasts.
Right.
And so was it more a content-based way to make recommendations of podcasts?
Well, there's a multiplicity of interesting challenges there. Content is one thing, and you can get at it using transcripts if you turn a podcast into text. But that might not be the most efficient way to do it. If you're never going to read the text, if all you want to do with the text is provide the audience with the bits they want to listen to anyway, maybe there are smarter ways of doing it. So that's one thing. But of course, the main thing Spotify does with things is think about usage.
Yeah.
And how does the deep knowledge Spotify has of your musical listening habits translate into predictions for your podcast listening habits? It turns out it does to some extent, but it's not as simple as optimists would like to believe. But there's all kinds of things there that can be refined into a listening profile.
And you're being a bit vague here in describing it, and
purposely so.
I can understand that to some extent. I still try to answer some questions, but feel free to say, this is not something I can speak about if you can't speak to in too much detail for obvious reasons. But I guess for people that are into recommender systems, there are some traditional techniques that are very well known, like collaborative filtering, where you try to match, what products, songs, movies, or podcasts that you have listened to, try to find similar users and then recommend, the similar podcasts that you haven't listened to. But then you can also have more content-based approaches.
Yes, both of those are in play for any kind of product search. Podcasts are a very specific type of product. Now, the huge challenge with podcast search is that podcasts are a moving target. So podcasts now are not the same that they were a few years ago, and a few years down the line they will be different again. So you can't really lock down what podcasts are and say, okay, this is the way we're going to do it, because they change. And this is a prediction I like to make, and feel free to put a pin into it and remind me in 10 years' time. But I think 10 years from now, we won't be talking about podcasts at all. We don't talk about blogs anymore. We couldn't stop talking about blogs. 20 years ago, we couldn't stop talking about blogs. 10 years ago, blogs were still a big thing. And then all of a sudden, no one talks about blogs. They're still there. People still write things on text. They do microblogs in various formats. There's all kinds of competitors to Twitter. And there are blog platforms such as Substack and Medium, and people write posts on LinkedIn and even Instagram. They used to write essays about things that make them happy or annoy them. So blogs haven't gone away. We just don't recognize them as a monolithic genre. And I strongly expect podcasts to go the same way, meaning that in 10 years' time, I think people will be, speaking on in various ways, and these will be streamed and distributed in various convenient ways, and they can be consumed in various convenient ways, and people will be delighted and appalled by the stuff that's being said. And they will talk to each other about, did you hear that interesting lecture? Did you hear that interesting conversation? And did you listen to that comedian? Or I took this class on how to bake sourdough. That's probably gone by then, but how to do something else interesting. But they won't call it a podcast. No. Why should they? Why would all recorded speech be subsumed under one single label? I mean, we don't say, oh, have you read... Oh, actually, we do we? Don't we? We say, have you read a book recently? This is something people have started to say because book reading has.
But we don't say, have you read this blog article perhaps that often anymore?
No.
We simply say, have you read this article?
Perhaps? Have you read this essay? Have you read this thing someone wrote?
So in some way, the format of speaking will be commoditized in some way, or it will be normalized in various ways that... And I guess the whole term pod it originates from iPod.
I think that's the origin of the term. Inspired by the iPod. There's a reference to some journalist, I think, in Britain who first used it. Gordon is looking up the origin of the term. There's a known first originator of the term, and I should probably memorize the name because it's quite useful. But
it's iPod and broadcast.
The Guardian journalist Ben Hammersley in 2004.
Interesting.
Right. So that was and the cast bit is more interesting than the pod bit, essentially. And now we call them pods rather than podcasts.
I agree. You will be correct in that. It sounds plausible.
Because now I've seen the evolution of the genre even in the past few years. There's more and more really well-produced shows that are essentially drama theater with sound effects. You hear doors opening, people walking up steps, creaking steps, and then yells and birds cawing and all kinds of things going on, as if it were a movie soundtrack and mood music to boot. But at the one end, and at the other end, you have these, a couple of dudes blathering about something with an iPhone on a bar table, and that's also a pod.
Well, it makes sense if you see it, because if it's a mixture between iPod and broadcast can be whatsoever, right?
Yeah.
So it makes sense.
But people don't really talk about, did you listen to this broadcast?
Yes, exactly.
Did you listen to the news? Did you listen to that lecture? Oh, there's a really interesting show about X.
Right.
So there are all kinds of ways, but the general term of broadcast, which is about the technology used to distribute the thing, isn't used as a label for the whole thing.
Right. But in this term, I think the broadcast is more like it's a live broadcast or it's recorded broadcast of something, right? Like we had it in the 90s with when you had like a radio broadcast or something like that. So yeah, that is a good good prediction actually.
Yeah, well,
It's too broad.
feel free to remind me in 10 years if I'm right. But this I make wild predictions at times, but this one I'm not too worried about.
Me and Anders usually make these stupid bets and we put them 5 years and 10 years ahead in our calendars. So maybe we can
there is a service on the net that will remind you of.
We should use that one. So I will win and collect the prize every time I win the bet.
Never.
Awesome. Just briefly, also, you just joined Silo AI, and we had Peter Sarlin here last year as well. But perhaps you can. I understand you just joined, but if you were to describe, what is really Silo AI? How would you describe
Silo
it?
AI has been around for a few years now, not terribly long, but it's grown very rapidly, and it's now 250 people. I think 250 consultants. It's a consultancy, AI consultancy, helping customers put smart things into their products. Customers that are not primarily AI purveyors or AI developers, but they want to have a bit of intelligence in what they're doing, or sometimes for internal processes, sometimes for the end product. And Silo AI is there to hold their hands and help them develop and build and test and evaluate.
With 100 plus PhDs as well, right?
Yes, more than half the employees have a PhD. So it's a pretty cool crowd. And so with that experience, how to generalize over those customer projects and be able to do something sensible for future customers using the platform that we've building a platform out of what we learn, essentially, is what SiloGen is about.
And they recently made a big announcement as well, launching the SiloGen. What is that? Well,
since this is I've joined just a week ago, so with all the weight of my experience, I can say that what Silo AI wants to do with SiloGen is to explore the space of generative AI, what we out in the world today know as chatbots and image generators, and see how that technology can be used usefully and fruitfully for customer projects, and developing what needs to be developed to make that happen.
Awesome. And if we just speak a bit about, for people that may not are completely familiar with what generative AI is, and I can give my kind of way of describing it, and please let me know what you agree and disagree with about that. And AI, of course, has been around for a very long time, like 70 plus years. And initially thought you can simply build a system by programming all the rules manually. Turned out to be really hard, but for some use cases it does work, and it
wasn't a bad idea.
It was optimistic and could potentially have worked, but still do for some use cases. You can potentially.
We haven't run that idea into the ground. It's still helpful in some cases. Yes, absolutely.
And then we had some new algorithms coming about that made it popularized to instead learn the rules automatically by feeding data into the machine, and that caused the field of machine learning to grow, and then a set of rather successful examples of especially how to work with structured data came about. And it caused all these kind of, XGBoost and light GPMs and whatnot that we have today and still use today to a large extent to work really well for, I would argue, new use cases that wasn't possible with the traditional kind of symbolic AI or the traditional manually programmed AI use cases. So new use cases was made possible by these techniques. But still, then we had a number of issues with that. It couldn't really work with unstructured data like images, text, and audio in a good way, especially language. Perhaps that's your specialty. But I guess you could disagree with me there. But then you had some other new techniques that came about, especially neural network-based, that were more of a deep learning type of technology with large number of layers that allowed you to represent the data, especially the unstructured data, in a new way that made it possible to understand. And I phrase that or make that
that's
term.
a big word, but yes, in some sense, yes.
At least try to interpret, if we call it that. the unstructured data and text, images, audio in a more efficient way than possible before. And then potentially the last 2-3 years, we also seen an explosion of generative AI. Although generative AI has been around for a really long time, in different ways of doing, generative type of language, for example, like RNNs or LSTMs and whatnot, but also other techniques, of course. But it's been an extreme explosion in terms of how you now can generate text primarily, but also other things like images and audio in a much more semantic or efficient way than ever possible before. So I would argue once again that it's opening up for new use cases that we couldn't do before. So it's like a fourth level of AI that hasn't been possible before.
I think everything you said is along the lines with how I would think about it. So the first steps of machine learning were about using those rule-based models you mentioned early on, and then attaching weights to them and adjusting the model when it met with the world, which is an excellent way of doing things for certain.
Yeah, easy to understand at least.
And easy to debug, transparent, editable, and all kinds of good things. And also very useful if what you do is in a limited world, and also in a world that isn't too dynamic. But language doesn't really work that way. And as a linguist, of course, I should be distressed by the fact that these recent models have proven so much better than all the grammars and lexica that some of us have spent decades of our life poring over. But
was it a personal problem or issue that all the techniques that you have worked with so long?
Not for me personally, since I've been. I was arguing for statistical models very early on. I was, this is actually difficult even for me to remember properly, but in the late 80s when I signed up as a grad student, databases were a huge research field. There was a frontier. People talked about database models, database engines, conceptual modeling was a big thing. And there was this little tiny field of information retrieval which used statistical models to do essentially the same thing as database did. I gravitated towards the information retrieval field, and it took a couple of decades, but information retrieval became a vastly larger field than the database field at some point. I forget when, but somewhere in the mid-90s probably.
The Alta Vistas of the world. And
Alta Vista and then Google and the web happened. So all of a sudden there was a need for tools for working with non-catalogized data. So that's a whole step towards it. But then language has this wonderful and slightly scary characteristic of the items that you use to communicate in language. Let's call them words for now. They bring with them. They have immediate local constraints, which is why people try to do grammars with them, because there's just so many words that can immediately precede some other word. I mean, I have a glass with a liquid in front of me, and there are only so many things I can describe what I will be doing with that glass. That's one thing. That explains why we're preoccupied with grammars and lexica. But the other thing that glass with the liquid does, amber-colored liquid, slightly fizzy, with which up until now had a little bit of foam on top of it, and it gives you a connotation. It explains what sort of situation we're in now, and it explains why we talk a certain way. It sets the tone, and every word contributes to that in a conversation. There's just so much information imparted by each bit of a conversation. Even the way you construct sentences carries with it. They carry with them the ways in which we want to continue the conversation. And modeling all those, it is a huge parameter space. There's no way around it. If we want to predict, if I'll say I'll just have a drink, or I'll pour out some beer and here's a brewski, or whatever way we express what we're going to do with that liquid, that sets the tone in ways which are very predictable for us humans, especially those who are, if you're from the same culture and have the same background, and if you're used to the same sort of situations, then you can say a lot with just the one word.
You can, and I'm going to add a question here that we're not going to answer now, hopefully, but add it to the more philosophical questions in the end. But you can start thinking about it perhaps, and that is, do you think that we can reach AGI by only training on text and language?
No.
Okay.
Strong no on that.
Okay, but let's elaborate more on that later.
Happy to, yeah.
Because some people think that, but some most.
Well, they let's call it the wrong view.
In a very humble and polite way, let's call it the wrong view. Cool. Let's get back a bit to Cytogen at least. So we can see at least, I guess, that we have these kind of new use cases for AI. But why is it? What's the need? Why was it necessary for Silo to create this kind of? Is it a project? Is it a branch of the company? Is it an initiative, or what would you call Silo?
All of the above, I guess. It is an initiative, an effort within the company to build something more general than what we've been doing in the past. And why it's necessary is, well, we see client needs, customer needs that have to do with AI. And in the past, most of them have been instrumental in the sense that let's do this thing slightly smarter. Let's build this product in a slightly smarter way. Let's make sure this thingamajig is personalized for various customers. But what with the current interest and exuberance about the possibility of the generative AI. So I should say something about generative AI as opposed to the previous set of AI. So the point of generative AI as opposed to the previous generations of AI is that where AI has been about modeling the world and predicting actions or suggesting actions or essentially classifying things and observations, generative AI is taking that representation, which is what AI is about, taking that representation and then generating descriptions of the world based on those representations. So instead of just observing the world and then lighting up different colored lamps.
Like you said, understanding as well.
That would be understanding in a very bleak sense of the word. Say, okay, here's the blue light lights up. This means that this thing is going on, and the green light lights up. That means this other thing is going on. That's, in some sense AI, and then you adjust it a little bit based on what you learn. That's a very simple. Today we wouldn't even call it artificial intelligence. We used to, but because it was AI in its time. But today you'd use the representation you've built to handle those little classification systems or diagnose systems to generate stuff, to provide a description of something that you didn't describe before. So that's the difference. And what with the current interest in such tools and the obvious, the mind-boggling nature of what they're doing, customers feel that there is a use case. Clients see that they can provide better tools using some of these generalization steps. So there's an interest in doing these sorts of things. Now, how do you build those things? Well, you take a lot of data and you represent what's in the data in a suitable form. For instance, in a vector space built by a deep learning model, by numerous parameter spaces being tuned to fit and describe that reality in some interesting way, and then you essentially reverse this process and kick the machine a couple of times until it tells you interesting things about what it knows, what it understands, as it were. And now, doing this involves using a lot of data. And where are those data from? That's sort of one of the big challenges for today's models. How do we build those models given the data we have available to us? Who owns those data? What's in those data? Can we do safe things with those data? Are we treading on someone's toes? Are we leaking stuff that we shouldn't be leaking? Are we telling our competitors what we know that we feel that they shouldn't know? So given all those concerns, many commercial and non-commercial organizations need help in deciding how to make use of these new wonderful technologies and deploy some of those use cases you mentioned earlier.
Cool. So I think you used the term like new use cases that AI can be used for, and I certainly agree with that. That's new use cases and tools that can be built or improved in various ways thanks to generative AI. Would you say that's the main change that will happen, or do you think also that traditional AI use cases will be replaced by generative AI?
Oh, yes, absolutely. Some of them will be replaced by generative AI, but I do believe that much of what we know from traditional AI will be useful in guiding generative AI in the future. I mean, I don't think we've seen the end of rule-based systems.
No.
Because, as we said earlier, they're inspectable and editable and transparent and all kinds of good things. So if you have an entirely black-boxed model of interesting things, you might want to guide that black box in some way, and that's where rules come in. We're not doing it today. That's not the way we operate today, and but we will get there.
We have a topic later on how to guide these kind of models, and if it's rule-based or other methods that could be fun to speak more about. Especially coming back to your original kind of question about you being dead by the current AI system.
Yes, that was an interesting experience.
Okay, cool. So Silogen then, they are going to explore a bit, I guess, how to build these kind of tools and models, and also how to build applications on top of that, or
right, and how to tailor the existing models, some of which are prohibitively expensive to build, but are very general in their nature. How can we make use of them in specific use cases by fine-tuning or tailoring or building a pipeline of processes based on proprietary data or sensitive data or even confidential data in various ways? How can we make something happen without distressing people who are involved with those things happening?
So what's the need for it then? If I were to challenge a bit here, and I'm not agreeing with what I'm saying here now, I'm just trying to see what you think about this, but we have an API for ChatGPT available. We have soon probably Google and other companies coming out with APIs for doing that. Why does Silo need to have Silogen when we have these kind of APIs available for the companies?
Well, it's unlikely that every company out there that wants to build a product wants to donate their data to some other entity in another type of jurisdiction that they're in. And also, ChatGPT just killed me off, and you'd want to have someone to make sure that what you're building to your customers doesn't kill them off as haphazardly and
donate the data, yes, and also to, I guess, fine-tune, as you said, to their own use cases with their own proprietary data that they may not want to send over the internet potentially.
Yes, and there's several levels of sensitivity in proprietary data. It might just be proprietary. It might just be it might be overblown. Concern, but you have a competitive advantage in your data. You might not want to share it, and it might contain sensitive things. You might annoy people if it becomes known, and it might be confidential. I mean, you might get sued if it gets, and all those different levels of sensitivity need to be addressed in ways which can be, which are sort of couched in a customer-provider relation in a trustworthy way, and also. Coming back to it, quality assurance is a thing, and we've gotten fairly used to the fact that software doesn't really come with quality assurance, that we're all beta testers. But if it's a business-critical application, you'd want to have some sort of sense of where it's going and how well it's doing.
And I guess also that Silogen, I mean, it's at least an issue that I have personally when I get asked about questions about generative AI and especially ChatGPT is that they think, this will be super easy to build whatever product you can think of on top of it. And there is nothing stopping them from doing it directly here and now. Do you feel that kind of, because I guess the reason is it's made so public and as a free service, very easily accessible for any kind of non-technical person. So they simply assume that now it's super easy to build whatever product you can on top of it.
Well, I'm sure some people will, and some people do already. But it's ChatGPT is not the end of history to begin with. There will be other technologies that replace autoregression and so forth. But and a chatbot is only as useful as what you use it for. And not everyone needs a chatbot. There are many ways in which you might want to use generative AI that have nothing to do with conversational interaction.
Awesome. Can you perhaps speak a bit about the technology that you're planning to build, and perhaps if there is anything that you plan to contribute to large language models at Silo?
Well, I don't think we want to share a technology roadmap at this time, but I think we can safely say that there's a future where foundational models are exactly that, foundational. And again, this is not Silo AI speaking, but me. I suspect strongly that the foundational models will be better than today's in many ways, but also probably reach not quite as far into knowledge as they do today. So there will be foundational models that are excellent with, handling language and modeling a conversation. But then you will want to have tooling on top of them that provide it's already today obvious you need other tooling to provide a product. But there will be many layers between that end product that handles, say you're a financial institution and handle the conversation with the customers about their accounts. That's a fairly constrained register of human language. And at the other end, there's a foundation model that can handle any number of languages very handily and knows all kinds of things about how humans communicate. But you'll need a separate layer that handles the knowledge about this, about what you're talking about, the actual banking stuff, and you'll need guidance for the model. What are you allowed to say? Because the chatbot can say the damnedest things. We know that from playing with ChatGPT. And so there's a bunch of layers there that you need to handle. And so there's we haven't ironed out, we as a field haven't ironed out all the business models that are there to build things in. But there's plenty of structure that has not yet been built. And there's plenty of structure that hasn't even appeared on the drawing board.
I can imagine. And I think this is a really or impossible question to answer, but you mentioned some practical applications, and if you were to just try to think about potential practical applications, or even like industrial sectors perhaps, or type of companies that you think can find value from generative AI, can you try to imagine or give some examples perhaps?
Well, and this is again not Silo AI speaking, because I have too little experience and no mandate to speak on Silo AI's behalf. But I see I guess three ends. One is the thing the first one is the one that's easy to envision. A customer service bot, just conversations with people. If you can make sure that most of the conversations with your customers or providers or whoever calls you up can be handled automatically, that'll save a lot of effort and time. And it's dull work and drudgery for most people involved. So if it goes efficiently and quickly, everyone will be happy. And you'd get rid of a bunch of people flailing around in your web pages trying to find information if you have a really useful customer service bot there. There are customer service bots out there, and some of them are mediocre.
But most of them are horrible, I would argue.
And it doesn't get better than mediocre.
Yeah.
And if we can make them excellent, we're doing a pretty good job. The other end is, of course, understanding large amounts of human-generated content in general.
Yes.
And that's sort of like our previous employer, Spotify. If you have a wealth of information, flushing through your system, you can find stuff in it using a model. That's less generative, but you can do stuff with that information, extract information about it.
I guess generative AI techniques also have the ability to understand, if we use that term, data in a structural or in a textual format.
And I see I see in the very near future a marriage between these, the current generation of AI, where we build models that ingest large amount of data and represent them handily in as of today, a wasteful representation, but I foresee more efficient ones. And the other end of AI, where you have rule-based systems and explicit representation of knowledge, which is editable. And these two strands will intertwine, and there will be interesting ways of doing stuff together with both, so that you can represent your knowledge both as a graph and as a vector space, for instance. Well, and the third thing, I guess, would be, well, it's probably similar to the second thing, but there's a wealth of information hidden in servers on hard drives in every company around, and just recycling parts of it will be hugely useful and save a lot of grief.
I think that's a really good point, and I remember that from my Peltorian days as well. That a lot of companies, when they think of AI, they just think of like databases with structured data and what you can do from like a BI point of view, where you have some time series data that you can work with. But in reality, if you look at what is the most common type of data that companies have, I would argue it's potentially text.
We're in the habit of, we as humans are in the habit of putting everything important into text. That's what we've been trained to do for the past few thousand years. Everything important we know we put in text, and it's a semi-structured information form.
Yes.
And it's
perhaps we need to elaborate on that. So, I mean, superstructured is basically, you think of relational databases,
right,
and every field is described.
And those are less useful than text because they impose a worldview that might not be the one you want at runtime. But text leaves the structuring, the end process of structuring up to the reader at runtime. And you put in only so much structure as you want to provide at compile time, I guess.
I guess the completely unstructured is if you have the pure numbers or the pixel values or
a movie.
But at least language has some kind of structure.
It is semi-structured, and it's let's say it's structured enough to make people believe that it is entirely structured, and it isn't. So you frequently get confused by it. But let's say you have just a database of sales contracts, and the guy who wrote most of them just retired. If you can query that database in a conversational way, and you know that the data you're talking about is in the database, you're not querying the world, you're querying your own history, your institutional memory. I mean, that would save a lot of grief.
I think that's a good example. I got a question recently, how can you layman's terms describe what ChatGPT is? And you probably will disagree with this, but I couldn't, I had to think on my feet there and come up with a short answer. And my answer then was, think of ChatGPT or large language models in general as something that has taken basically a large amount of text, perhaps all the public text on the web, and put that into a small black box, like compress it into a small box. And then you can ask questions in this box about the knowledge that's comprised in that box, so to speak. Would that be a useful description of?
Yes, but I would like to be more precise at the very end, because you can ask questions of that box and it'll use that language it knows to say fluent things. Right. It won't say necessarily truthful things. It'll say things that sound good.
But that's just isn't that a limitation of the current version? I mean,
it's a limitation of the current version. It's a limitation of the training objective we have. Yes. We're essentially the systems are training the model. They're building the models by a fill-in-the-blank game. Right? Guess what word is here, and if it guesses the right thing, it gets a carrot. Otherwise, it gets a stick. And so it's very good at guessing what should be the next word or the next character in a sequence. And this is all good, and it makes for very fluent and very convincing language. But it's not been ever slapped for saying an untruthful thing. That's not the way these have been trained. We're now doing RL feedback to do that, but that's very indirect.
But perhaps we should move to that topic, because we spoke about that in the beginning a bit. And if we just try to identify a bit more clearly, what are the limitations of current large language models and potentially how we can start to fix them? What you said basically then, for one, they've been trained to simply produce text in a fluent and grammatically correct and confident way, I guess, as well.
And confident, yeah. They sound fluent. And since we've been trained the same way, they will say things that look like they should. We as humans have been trained the same way. It's remarkably easy to believe that what they're saying is true.
Yes.
And mostly it is true, because as a side effect of generating fill in the blank stuff, mostly what you say will be true. And I ran the experiment the other evening with some friends and asked them, tell me untruthful things about helicopters. And it's very difficult.
Yeah.
So say an untruthful sentence about a helicopter. Oh, look, your eyes are rolling already. This is
it is tough. And the human brain is so locked into doing the opposite.
Because we usually say truthful things. And
helicopter can swim, I guess.
That was more or less what my colleague said that time. He said helicopters are underwater creatures. Oh. And then continue, please. And then it was very difficult. You lose fluency because fluency, you take the easiest path through your knowledge base. And so these models, as my colleague Magnus likes to say, they're trained to play the language game, and they're not trained to play Trivial Pursuit. They're trained to play the language game.
Mm. But to do that, to play the language game and to generate fluent text, at least they need to have, for one, details about the world and potentially some way to reason about that as well. Would you agree?
Was that a description of the world as it is today?
The large language models as they are today.
Well, the second it doesn't have.
Nothing, no reasoning capability?
People would sometimes disagree with me about this, but I would say that they lack entirely reasoning capability. All they can do is manipulate language. Mm. And insofar we call semantics a linguistic category. Yes, they're a full-grown semantic model, but they lack meta-knowledge. They have current language models don't really have internal states. They cannot modify that state. They have no intentionality. They don't intend anything with what they're saying except filling in the blanks to make the conversation look nice. Now, we humans, this is a very specific sort of interaction. I'm saying complex things, and you're saying complex things, and we're banding about these complex things, and there are people out there listening to this. Mm. But even here, much of what we try to do is to, make people feel good about things. We're having a nice old time talking about these things, and we hope the audience is, hello audience, hope you're enjoying this show. Mm. But that intentionality overrides truthfulness. This is why people lie.
But I guess we need to go into what we really mean with reasoning, because, we could see I'm not sure if you saw the GPT-4 demo that we had. They had it.
No, I didn't see it yet.
Okay, but they gave some really awesome examples there of what it can do. For one, the tax example, I'm trying to recall exactly how it worked, but I'll paraphrase it a bit here now. Mm. And for example, would you say that a machine that can play chess, can that machine reason, by the way?
No. It has no meta knowledge. It doesn't. You're not able to tell it play differently. You're not able to say, look, what you learned the last time is different, and look, these two games are similar. There's no.
But it can learn from those two games. And
it can learn. It can adjust some stuff, and on some level, of course, we're all molecules. Yeah. But the way we process the world includes inspectable and editable knowledge. Look, here's an example. When I was a kid, I read all the Tarzan books when I was about 8 or 9 or 10 or something. Mm. And I was very pleased with my understanding of how life in Africa is. Mm. And I was gently encouraged by people around me that to understand that maybe that picture of Africa was incomplete and obsolete and maybe even fully wrong. Apparently, the author of Tarzan never actually visited Africa. So, and that was a learning moment. And the amount of data that I'd ingested about Africa up until then in those Tarzan books was considerable. There's a bunch of them. And that moment when I was taught that this was not the case was a meta-learning event. I was told, look, what you know is probably not true. I wasn't told, although, sometimes kids are told this, and sometimes people on Twitter tell each other this, go read another book, go back to the library. That's not a helpful way of learning things. But I was told, look, you're wrong. And you can tell people, no, what you know from those old books is not true. Women can become medical doctors. And this is, all of a sudden that insight trumps everything you learned so far. Even though the amount of data is minuscule, that's much more important. And that is an instance of meta-learning. You sort of learned that what you learned was different. And then you're not unlearning things.
Couldn't you take that to the chess example, though, to say that you've seen 1,000 examples of how to play a certain position, but then suddenly you see a single or a few examples, and it will completely change how it forever will change that position, given these few examples?
That would be a very good chess computer. Now, I haven't played chess against computers for many, many years now, so I have no idea how this... and I understand that I understand from this the recent news about someone being caught using a computer is that the playing style of a chess computer is recognizable for human players, which is an interesting thing.
So Magnus Carlsen, he's the world champion, arguably, but it's been for 10 years at least, and he can tell, I think, in a few moves if it's a chess computer or a human. And of course, no human can ever beat a computer today in chess, but he can. That was an example of, just to give a background of what you just said, because I think it's a fun example. And
right, I think the understanding is that a chess computer can figure out a winning strategy, but it's fairly brittle in the sense that these moves can only be a winning strategy if a lot of other things happen later on in the right way. And the chess computer is able to model that, but a human would play in a different way to achieve the same.
Well, a chess computer, I would argue today, can handle any kind of situation the human brings to it and win still. So I think it can adapt easily, and it's not as brittle anymore at all.
Yeah,
but just to give the example,
obsolete.
Well, today you have no chance whatsoever against a chess computer. But in that example, there was this 19-year-old, if I remember correctly, American chess player who was potentially beating Magnus Carlsen. And he was having another game, and Magnus Carlsen just left after, I think, 2 or 3 moves in that game. And he basically left in anger because he says, I can directly tell this is actually a chess computer playing. No human would play it in this way. And he knew would have no chance in winning then if he's cheating. And then there was some reasoning about how we actually did cheat with some, not to speak publicly about kind of nasty things in his butts and whatnot, kind of sensor or whatever kind of electrical impulses that he were able to do. But that's I think is an interesting example. But okay, if you don't consider chess to be reasoning, what do you consider reasoning to be?
Oh, wow. Well, yeah, let's see now. I think you can reason about chess. And it is not inconceivable that one might have a chess computer that would be able to reason about chess. I'm not saying that chess is incompatible with reasoning or that a good chess performance is not reasoning. I'm just saying that playing out a decision tree to the end and having a cost function on each edge in that decision tree, that's not reasoning. Whereas the way you would approach an intractable problem by arguing about the problem, not about the moves in the problem, that would be reasoning. But I'm really on thin ice here. This is I am not a knowledge theorist. What I know very well is language and theories about language. And I do know this. Language in itself is not knowledge. Language is the carrier of knowledge,
Right.
and being adept at language games doesn't make you a wise or a knowledgeable person. This is true even for people.
Yeah.
I have been the examiner of students who think they can get away with smooth talking instead of reading the book.
Yes.
It's very noticeable when they trust their verbal capacity more than their knowledge.
Could we get back to this topic? Because I think that's interesting, when you speak about how to define language. And for sure, it has a syntactical part of it, but potentially also a semantical part. But before we go there, I just want to keep speaking about the reasoning part. And okay, you don't have a clear definition then, but can you, if we were to have a bit more general sense of reasoning, if we were to say that reasoning is something about trying to consider some state and a number of steps that you take to achieve some kind of goal in some very, very broad way. And then you would argue that, okay, if you have reinforcement learning like AlphaGo or AlphaZero or something that even learned how to play chess without ever looking at the human chess game at all, and just learned by playing itself and became unbeatable, of course, that at least it can reason in that kind of narrow way about how to play chess or Go or StarCraft or whatnot, right? If you have that kind of loose definition of reasoning.
Yes, I guess so. But I really feel I'm on thin. I mean, the literature on knowledge theory is extensive, and I have not even walked up to the bookshelf. Mm-hmm. So but there are people who, wiser people than me, have spent their lives thinking about what reasoning might be. But I would, from the perspective of a fairly expert linguist, I would say that reasoning is more than symbol manipulation. Mm. If you just take, I wouldn't say it's reason. Here's an example from mathematics then. If you know how to divide things using a division algorithm, you move numbers about, and then you subtract, you do 6 times 7, and you subtract 42 from the thingy, and then you have a little bit left over, and then you do the thing over again, and you have a remainder at the end, and then you can go beyond the decimal point, and you can do this. That's not reasoning. That's not reasoning about math. That's not understanding numbers. That's not doing anything except
that's following rules. Right?
That's following the rules and doing symbol manipulation. You can do it confidently, ending up with the correct result if you have your mind put to it properly and you don't goof along the way. Now you can do the same thing on a slightly higher level of abstraction with language. You can reason your way, using the word reason in an everyday sense here, through a problem just by putting things in order. Let's think about this logically, which is now a useful prompt for ChatGPT. But let's think about this logically. Okay, so I poured in the oil into that little canister, and then I pressed that button, and the thing went chug, 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 but nothing happened. And let's see, what have I forgotten? Oh, there's a little valve there that I need to open. And just using language as a symbol manipulator, this is... If I were to do it the same way as I'm dividing these two 7-digit numbers, that would not be reasoning. Mm-hmm. If it's grounded in something, and if I'm manipulating my own knowledge as I do it, then I would call this reasoning. But this again, I feel very bad about talking about these things, knowing that there are experts out there who are now pulling their hair listening to this naive. Now, I consider naivety to be a virtue, but I'm not knowledgeable here at all. But I would require of an intelligence to be able to call it reasoning. I would require something else except symbol manipulation. Yes. It's not enough to play the language game. Now, you said language was a syntactic phenomenon and also potentially a semantic phenomenon. I would remove the potential there. I would say, yes, it is a syntactic and semantic phenomenon, but to be a vehicle for intelligence, it also needs to be coupled to reasoning, intentionality, and not just the intention of putting the words in the right order. There needs to be more to it.
this is such an interesting topic. I'm sure you can speak like for hours about this.
Oh yeah, absolutely.
But just I'm trying to come to the point a bit about the original topic, which was the, what are the limitations of current large language models and how we can fix them. And then thinking about what you said about having an internal state, I very much agree with that. That we can see that GPT-4, for example, does not have an internal state, at least not in the exact trained model itself. Potentially, it has it in the user session or the topic session. That it has
it certainly appears to have, because it has a conversational state,
yes. And potentially also in Bing Chat, it has connected to Bing Chat, the search engine. And the search engine, from an information retrieval point of view, has the state of the world right now as it's fetched from the web, so to speak. Right? So potentially it has some kind of state there, but it doesn't really manipulate the state in the search engine. But potentially it manipulates the state in the user session. If
we're close to something quite interesting there. Yes, absolutely. But I would suggest that what we need for these, I mean, I come off as being critical of these machines we've built now, but I'm not. I'm enthusiastic and exhilarated and hope to see more of them. But I would venture that what we need is, besides the capacity to build coherent sequences of language, we would want the system to have a multi-objective, a multiple objective. It would want to make people happy. It would want to come off as seeming cool.
Cool. That's coming to the point, the last point of the topic, which was, how to fix them. And perhaps that's one way to do it. But still, I want to stress an even harder point here. So let's agree that we don't have an internal state that it manipulates, because the parameters of the large, hundreds of billions models stays fixed during the inference mode of this kind of large model that we all agree on. Potentially, it has some kind of external state that it manipulates per the user, and the search engine it can access, but not really, at least today, manipulate. What about, if we still say that reasoning requires some kind of state to be changed? We know if it's based on like GPT-4 kind of model with 96 or 100-ish kind of layers, just moving in the forward step from layer to layer 100 times, and then again, for coming iterations when it generates words, isn't that manipulating its own internal state?
Yes. Absolutely. I mean, we're getting there. I think this sort of architecture is probably a necessary component of something. I'm sure we'll come up with better architectures, but they will be inspired by these, and they will not throw everything out. I would say, I mean, just from a very, I haven't built any deep learning models myself, but my first take looking at them would be, why are all those layers identical? I would assume that we would want different types of layers to interact interestingly. Also, I would assume that we need a modular architecture, that we'd have one architecture doing one thing and another one doing another thing. I think there are interesting things ahead of us. And I will be...
well said. I actually agree on that, and to a large extent, of course. And also, it's similar to what Jan LeCun once said, speaking about his... I'm not sure if you read the JEPA paper, this kind of joint embedding of... Yeah. And he has a very interesting architecture proposal. I haven't gotten my head entirely around it because it's quite complex, but he says much the right things. Yeah. And he's been saying he's saying more right things now than he did 10 years ago, because then he was on a different frontier in a way. Cool. Well, I very much agree. We have a very interesting time ahead of us, and I think a lot will need to change and will change. Right?
Yes, the situation is excellent. We'll have plenty of things to do,
and not least in SiloGen as well.
Oh, absolutely. And I do believe that there are, like I intimated, there's a bunch of components that we haven't yet started thinking, we as in general as the field haven't started thinking about, that we will be needing to start think about when we turn what we see today into productive tools.
I think if it's okay, should move a bit more to some other more philosophical topics. By the way, were you part of training on Lumi and this kind of big cluster in Finland?
I haven't worked on Lumi myself, no.
Yeah.
So I can't say anything sensible about them.
Yeah. Otherwise,
the FinGPT is trained on Lumi. That's about my extent of knowledge about Lumi.
Yeah.
So
I think Silogen, what I heard from Peter at least, we're planning to use it. And
yes, I think that's in the plan, absolutely. And it's a very impressive cluster. So we'll...
Yeah. And for people that may not be aware of it, it's a EU-financed large supercluster of compute, and to a large extent it has a lot of GPUs as well that you can train large language models like this. It's though based on AMD and not NVIDIA GPUs, which is interesting, but it should be possible to use as well. But perhaps that's something that we can hear more from Silogen in the future about, how to
I'm sure we will. People have very strong opinions about the various infrastructural issues. I'm not that kind of an engineer, so.
Awesome. There's been a lot of discussions in media in recent days about generative AI in general, but perhaps even to potentially take a pause on the development of language models that are greater than GPT-4. What do you think about these kind of claims?
Well, many people I respect and whose judgment I respect and who know even more about things than others have thought more than I have about that call for a pause and have landed in opposite camps. Yeah. So, which makes me feel good to vacillate myself about it. I'm in general an optimist, and I have never felt the need to sign that pledge. I feel that we'll just push through this and we'll come up with cooler things, and that this is a bad reason not to sign it, though. There are many things that are more dangerous than GPT-4 and 5. Mm. Another reason to be skeptical about it is, of course, that even if that pledge were turned into a regulation,
yes,
it would only affect 4 or 5 organizations in the world. Larger than GPT-4 means that, most of us can carry on with whatever we're doing, and it won't affect us at all. So it's a fairly ineffectual call to arms. But I can fully see why people might be worried. But I think they worry about the wrong thing, though.
Okay, why is that?
Because it's not the technology. I mean, they should worry about information imbalance. They should worry about power in the hands of the few, and they should worry about such things. They shouldn't worry about a machine reading text.
You said so many interesting things there. So if we move to, I like, very much what you said about they shouldn't worry about the technology. And I guess they should worry about the use cases of the technology, right?
Definitely. But even today, I mean, as a consumer, irrespective of technology, you have less information about what you're purchasing than what the distributor and the producer has. That's a bad thing. It's not as bad a thing if what you do is anonymous and happens often enough for you to learn never to buy that soda again because it wasn't any good. But if the decisions you make influence your life in important ways, and the counterpart you're negotiating with at the cashier knows everything about you and you know nothing about them, that's a worrisome thing. And information technology, unfortunately, has not spread information as efficiently to the consumer as it might have. It has improved things, it has. But sometimes, in many cases, the producer or the distributor knows more about the world than the consumer does. And that is worrisome. And of course, that we will need consumer protection. If we have, generative AI producing interesting works of art, I foresee that we will have, stamps on things saying made by humans and that sort of thing. I'm not sure if there will be of great help, but people will want to know these sorts of things. But I wonder about, in general financial transactions done today, that it's not a problem with generative AI. It's a problem that some people sit on all of the knowledge.
Right.
Or not some people, some organizations sit on all the knowledge, and they don't even know it because it's run by some algorithm.
I mean, I think that's connected to the in the hands of the few, as you said, and I think also that's a very well-spoken comment. And we all know that the big tech giants that we're speaking about here that have data about all the people in the world basically, and they also have the resources to take all the knowledge from the web or other data sources and produce these kind of huge AI models that basically put all the knowledge in a box, and you can ask a question and it can provide answers to so many different things. But it is limited to the hands of the few potentially. Well,
it's not even few people. It's not. There's no villain there. It's running on its own logic in a way, and there's no person there with all that knowledge. It's an organization that has its own. So that's something that we need to talk about. But I think we need to talk less about the number of parameters in a language model. And since I'm also convinced that future generations of language models will have less parameters rather than more parameters. So,
and perhaps more modularized, as you say as well.
Yeah.
So, but okay, so it's a hands of the few organizations rather than a few people. And why is that potentially worrisome, you think?
Well, any information imbalance is worrisome. That's what information technology is about, to reduce information imbalance. The idea is that everyone will be able to select what they want to know and find what they need and produce stuff they want to. We've been lowering thresholds for the past 70 years or so with the help of computers. But we need to counteract the centralization bias. But this is a political point, and this is where politics has a role to play. I'm very worried by politics barging in and saying things about technology because they don't know about technology. They'll say the wrong things. They'll regulate the wrong thing, and then we'll end up with a...
So what is the right way then? I mean, you said, I think, a very interesting point here as well, which is that, if you go in and try to regulate this and say that no one should be allowed to build AI models in this way or that model in that way, or even try to hamper innovation in some way, that could be dangerous. And of course, I agree to very much with that. But what should we do then?
I think you should approach everything from a consumer point of view. And if you begin by thinking, how can we help people make informed decisions about what they want to do with their resources and their lives? And not worry about some unnamed villains in dark rooms. Because today regulation on the EU level sometimes says, okay, we need to stop these nefarious practices. Don't worry about the nefarious practices. Worry about the experience on ground level. How can we make sure people get healthy food and are able to, read the books they want to? And get insurance for affordable insurance to protect them against stuff they don't want to be exposed to. If you start there, that'll help. And then technology is just a tool.
Yes. At least so far, and for a foreseeable future, perhaps. But still, there can be people that abuse AI, of course, and you can use it for autonomous weapons, or you can use it to ask ChatGPT how to build a bomb, or you can use it to obtain knowledge that is potentially harmful to a lot of people. You could use it potentially for doing propaganda type of campaigns, or for a number of potentially not very useful use cases.
Yes, people abuse printing presses and kitchen knives as well. And, it's absolutely the case. People will abuse AI. People will try to use it to trick people and make illicit gains on a personal level or on a political level. This is something we need to be aware of and I mean, we're well placed to counteract this. I'm not terribly worried. Be careful about what you read. It might not be true. This has always been true.
Exactly, it has, right? Well put. But then if we don't regulate AI, I guess you answered your own question or my question directly, but if we shouldn't regulate the technology, I guess we should regulate something else, and that's potentially the use cases then. Or what should we potentially do to...
Yes, I think, we should regulate practices that are at the end of the pipeline rather than what's deep in the pipeline. We shouldn't regulate enabling technology.
Yes.
And we shouldn't do this across the board, because then we will lose out on medical diagnosis if we regulate, illicit lending practices.
We gave an example before, Henrik and me, on another podcast, and we said, if we are regulating the technology, let's say that I have a hammer here, and it's very powerful. I can use it for a lot of good, but I can also use it to hit Henrik on the head. And that should be not nice.
Yeah, bad thing.
It's a bad thing. What should be the answer to that? Well, should you forbid all the hammers in the world? Well, no, because it can be used for a lot of good. But then should it be regulated to not harm people? Yeah, probably.
The action is what was bad. It wasn't a tool. And this,
Right.
of course, this is a whole... You can't make very principled pronouncements of this, because, of course, nuclear weapons are potentially a source of good things, and we should probably not have them around.
Right.
So there's no way of making a across-the-board decision about these things, which is why I think it's a wrong thing to make of any technology. You should make it specific to the actions we see being done, not to the technology. Because, like I said, if you regulate AI based on the fact that it's been used to trick people into purchasing stuff they don't want, then we will have less useful medical diagnosis and less autonomous vehicles, and we want those.
So then we should regulate people not to trick people to buy stuff they don't want.
Yeah, we should tell people off when they trick people, and make sure they understand what we said.
Cool. But then if we just continue the problem here and say that, okay, we have a certain state of AI today. You can do amazing things with it for medical purposes or whatnot, and for even, AlphaFold and all these kind of amazing things that you can do. But there are other people that say also that, the growth of AI is going very rapid right now. They also say that, some companies more or less have an arms race, or at least an AI race in some way, in putting stuff in production as fast as possible for marketing purposes potentially, and potentially before they even have vetted them or properly validated the products. Would you agree that this is the case and a problem potentially?
I think this has been a problem for the software industry since day one. I mean, we're all beta testers, like I said before. We're used to the fact that we get tools that are almost done, and then we report back when they crash, and then there's a new release coming up in a while. And certainly this is the case for many of the AI tools we see now. And the technology development is more rapid than the product development at present. So, I think we're building these things without thinking about applications at present. We're building them because we can. Which is cool. I think that's the way we should be doing.
As a technological nerd, you think it's really cool.
Yeah, this is the way we should be pursuing success. And then we every now and then we should sober up and think about, okay, what are we going to do with these nifty things? Because we've gone through cycles of AI winters and exuberant springs, and when we've had a disappointing trough in funding and so forth, we still have deployed much of the new technology we built during the past peak. And yesterday's science fiction tools are now mundane parts of our everyday life.
Agreed.
This is what will happen. We will see pretty soon really useful authoring tools, truly useful authoring tools, not just, prompt ChatGPT into writing my school paper, but actually helpful tools to help us put stuff into the right order and convincing. And this will be hugely useful, and we will forget about the awe we felt for them when we've used them in just a little while. We'll just take it as it should be.
I can hear you're an optimist, and so am I, so very glad to hear that. But if I then am forcing myself to be more of a pessimist here, just for the purpose of discussion, we can see, for example, that the GPT models of today can also generate not only text, but also code, for example. And it's doing that really well. I've used it quite a lot, and it's surprisingly good in helping you to program much more efficiently and even do things you couldn't even do before. Are you afraid about that there can be a point where it starts to program itself, where it starts to do self-improvement in an uncontrolled way, that you basically have a feedback loop saying, now you ask ChatGPT to, when connected to a car or to something with a web browser, it can go in and fill out forms or do stuff online, and then it starts to improve itself in various ways, because it can not only improve the parameters of the huge model it have, it can actually change the rules around it, because it can generate the code to do so.
It'll be hugely interesting to see that happen. I'm sure we'll run many experiments to try to see how this might come about. And I'm not at all convinced that we're even near any possibility of anything truly interesting happening, except for us technology nerds, because I'm very curious at seeing how this sort of feedback loop might be implemented. But I'm not worried at all. Yeah. Not at present. I don't see any reason to be. Yeah. I mean, there's plenty of doomsday scenarios out there, but I fail to see how they're relevant to the level of technology we have today and tomorrow. There's a far way to go until we have HAL around.
HAL or Skynet or whatever Terminator movie kind of thing you could think of. Yeah, I mean, well said and agreed. But still, if you were to be pessimistic and you think that, okay, you see how well Copilot X now, which is based on GPT-4, can generate code and documentation and do so many things, it's not unreasonable even today to think, if you just give it access to its own source code.
Well, it does need internationality to be able to do that, though. Why would it do it today? I mean, sure. I mean, I can imagine a case where the system starts doing things unbidden that we cannot quite control, and that'll be quite interesting. But as long as it doesn't have any, physical capabilities, I'm not worried at all. Yeah. And it will have physical capabilities, and that'll be quite interesting.
So I shouldn't talk too much about this, but let's say that we have a Tesla bot then. Elon Musk is building not only cars, but also robots, humanoid kind of robots, based on the same technology that Tesla cars have. And then, some people claim that, Tesla cars have, for one, the perception possibility from all the cameras it has to understand the world around it. It has potentially the reasoning capabilities in taking some action. On a car, it could be like brake or accelerate or do nothing or turn left or right. But if you have a Tesla bot, a humanoid robot, and then you gave that access not only to improve its perception models, not only to improve the neural networks used for reasoning purposes, but also gave it access to the source code it has itself, don't we get close to something scary?
It's a good start of a novel. We're not close enough yet for me to think about that as scary. I'm still mostly positively excited about the capabilities. But yes, I can extrapolate to the dystopian future as well as anybody else. I've seen all the movies, enjoyed them. And yes, there are risks ahead, but there's more of I see more gains ahead than risks. I can see stuff happening that's useful to us as humans.
Thank you for saying that. I really feel bad for myself right now because I'm sounding like an alarmist, and that's the least.
That's not your usual role.
No, I just had to take it here because.
No, I'm not. I'm not in the alarmist camp. I'm quite happy, and I think it's striking to see that very few people who know about these things are worried. Some people sound the alarm, and either they know rather little about technology, or they are very interested in sounding alarms.
Yes, agreed. It's kind of funny how even Elon Musk is claiming that they should pause AI when he's probably one driving it the most.
Right, but he's not building anything larger than ChatGPT, so he's happy to see others not build.
Exactly right. But he's potentially doing something closer to AGI, but that's not GPT-4. So, yeah. Okay, cool. Another topic. What do you think about the current state of AI research? Because you are, very strong from an academical point of view as well, in terms of academia versus industry. Where do you see the majority of the current research being successfully performed, in academia or in industry?
Well, the current models are they're all done by industry because of resource constraints. Yeah. And so that would, and the most interesting research at the technology end comes from industrial research labs. But since it's not open, it's difficult to assess its quality to some extent. Although we can observe and certainly see that it's hugely interesting and wonderful and cool. But the current models are also insanely wasteful. I've said this a couple of times already during this little chat, and distressingly inconsiderate about some of the aspects of building models well. And I would say that there's a huge potential for new breakthroughs to come from exactly those research groups that have a dearth of resources.
A
lack of resources.
Scarce. Okay.
A scarcity of resources. If you poverty is one of the mothers of invention, and if you want to build better models, if you give someone, everything they want, they won't build a better model. They'll build a larger model. So, we're not at the end of breakthroughs.
That's we all can agree on that.
And I would say that there's a huge potential in building stuff better than today's models. Habitable models that can run on wristwatches and we'll need them, and I think we'll have them.
Interesting. So
we know the clock frequency of the human brain. I don't remember it offhand, but it's not.
It's 1,000 hertz or something.
Yeah.
So it's very far from the gigahertz of the CPUs for sure.
Yeah, and we claim to be building neurophysiologically plausible models, and yet we're wasting resources.
Yeah, but still, I think if you count, I'm trying to recall the exact numbers here as well. But if you take the number of neurons or the number of synapses in the human brain versus today's AI models, I think the number of neurons, and please correct me if I'm wrong, is around 86 billion or something, and we have hundreds of billions of parameters at least in the models. But if you count the number of synapses in the brain, it's at least a factor 1,000 higher. So then it's like hundreds of trillions, which is far above any kind of model that we have today. And I think it's more proper to compare number of synapses with the parameters.
Yes, absolutely. Those are the parameters, yeah.
And then if you also think that all the neurons work in parallel and is not, synchronous at all, and they also have a time dimension. They both have, the state and a weight, I would argue. Synapses is just a weight, but you also have a state inside the neuron. And they also have like a time dimension to it that influence how they function. The functionality of the human brain neuron is insanely much higher from a computational point of view, I would argue, than the current largest models.
Absolutely, and it doesn't map easily to each other. So there's a long discussion there that we haven't looked at. We have numbers here on the screen saying that
the cortex. I think that's just the cortex. But if you take the whole brain, it's closer to 86, I think. But it doesn't matter.
In any case, but we train these models on many orders of magnitude more data than humans.
Yes, but still, if you count the bytes coming in through the eyes and the rest of our sensors all the time, it's not a small number.
It's not a small number. No, this argument can go on, and you can slice these data in very many different ways. But I still see that the models, there's been no push towards parsimony there, and so I would say that I expect there to be interesting developments when we try to put these models into smaller processors, into smaller.
Yeah, agreed. But still, going back to the question about academic versus industrial kind of research. So then, if I understand you correctly, you can basically say that due to the scarcity of resources in academia, we can potentially expect some of the bigger breakthroughs coming years to come from academia still.
I would expect some great breakthroughs to come from academia. Yeah. I think for this to happen, academia needs to have a direct contact surface with application, with real needs. And that they need to come out of their, academia has certainly reformed a lot during my career, but it's still somewhat insulated. I'm only speaking for the techie end of academia here. And even if people wander from academia into industry, relatively few people from industry wander back into academia. And that's, I think, there's something there that academia as a human activity needs to think about. Why aren't more industrial researchers interested into moving into academia?
You don't think it's simply the monetary gain that you get from going from academia to industry, and they pay huge salaries, perhaps?
Certainly. That's a motivating factor for people to stay in industry. But in industry, you have the academia has interesting good sides to it, but those aren't exploited enough by academia, unless there is a stream back of people. And much of it has to do with the entry criteria to come back into academia. It's very difficult to break into it if you've stayed out of it for a while. Yeah. Both you and I started out in academia and moved to industry. And it's difficult. It would be difficult to gain a desk today at a prestigious college, other than temporarily.
Yeah. No.
But there's something there that needs to be fixed. Right. I think that needs to be a bidirectional flow, because the best way to move information is to move a person with that information, and that's not happening today.
Well said. I think there are some opportunities for academia to improve in that sense, right?
Academia is a fairly conservative part of the world. That the organization of academia is essentially the same as it's always been. There needs to be a bit of invention there.
What do you think about research in industry, though? In companies like Silo, for example, or in Spotify, or in companies like that? Do you think we know the tech giants are, of course, conducting research, but do you think there is a chance that should be improved or could work?
It could be done much more openly and efficiently, and I think it will be. And during my career, I've moved further and further from academia and deeper into industry. And at each move, I've been surprised at the openness and the willingness to take risks in industrial research. It's not just about the quarterly numbers. It's about true curiosity and let's try this. Then there are stumbling blocks. It's sometimes a bit more difficult to find time to report and publish. More that than there being a hesitancy to actually publish the results, but it's that there's always something else to do. And I would love to see more industrial PhD students that work full time, but spend some of their time at universities. This is for academia to fix because they're not welcoming to that sort of setup.
Well said. Well said. Okay, as a close topic to this, academia versus industry, and how both academia should change, I guess, but also industry should even improve their research activities even more, I guess. For one, I get a lot of questions about, what are the differences between engineering and science in different ways, and I have like my way of saying it, and it would be fun to just hear your thoughts about that, or if you have a better way to describe the differences. And one way to say it is that they are, of course, very much overlapping, but there is a clear difference in terms of the purpose. So the purpose for engineering is to build a product that is of use for some users. And the purpose of science is to build knowledge. And that's the big distinction. Then to do science, you do need to have some engineering skills to build some prototypes or whatnot, but the purpose is still to build some knowledge. That knowledge can be then, distributed in different ways if you want to. You can keep it yourself, or you can publish academic papers, or you can build prototypes to demonstrate the knowledge, or you can construct patents or whatnot. So there are different ways to distill or disseminate that knowledge, but the purpose of science is in that way. And the same for engineering, I would say that you need to have the knowledge to build the product. So therefore you need the science, but the purpose of the work you're doing is for the goal of producing some product. Would this be a fair way to describe it, you would say?
That's a fair way. I mean, essentially what you're saying is that the purpose of engineering is to fulfill the needs of someone who's outside the room. Whereas for science, there doesn't need to be a customer, or the customer might be the scientist or the researcher themselves. I always like to think about if there's a question we need to address in some project or effort or lab or whatever. It's if we know the answer, but don't quite know how to get there. That's engineering in a way. But that doesn't bring in the customer. If we don't know the answer, then it's research.
Yeah.
And sometimes you need to resolve a question to be able to build a product, and then a product company needs to do some research. And if they don't know what the answer will be, that's research. If they know what the answer will be, that's an engineering project. Then just make sure to build it. And there might be disappointments getting there, but we need to build this. Let's build it. But that doesn't bring in the customer bit, which I like better. So I think I like your slicing better.
Even if you know the answer, you want to bring people to Mars or something. There are so many sub-answers you need to obtain to obtain that.
Where you don't know the answer.
Yes. So then you have still the need for science there.
Right. And the top level goal might be clear, so these interact. Yeah. And this is why industry needs to do research. It's not just about, serving up another meal.
Awesome. I see the time is flying away here, and moving into some of the more closing topics. And if we just continue a bit on a more long-term question before we move to AGI topics, but if you believe that, or what's your belief in when we will have, or do we have self-driving cars on the streets today, in your view?
We don't have them on the streets yet today. I mean, there are prototypes out there that behave decently.
There are robot taxis in limited, areas and whatnot,
and delivery robots and such things.
Yeah. But I guess there will be a point, and we made a bet about this for not too long ago. If we ask the question like this, in 5 years, will more than 50% of all cars being sold have full self-driving functionality? What do you think about that?
5 years and 50% of the new automobiles. Full self-driving.
Yes. So then you can ask what that is. Is it level 5 or is it, yes?
Yeah, so there's a question. I do believe that 5 years from now, more than half will be able to park themselves. You just leave them. I mean, I can see you could leave them outside the garage, and they will, and you go into the restaurant, and they'll take care of themselves while you're doing more fun things. And that when you enter the highway, you can just flip your seat around and play cards with your family. But full self-driving in a messy environment, more than half. Meaning you could actually disassemble the steering wheel entirely.
Yes, exactly.
No, I don't think 5 years. No, I think acceptance. Part of it is because the acceptance of the general public to this will be low, and thus the regulatory constraints will be low, but will be higher than we would like them to be. So I think because there will be, self-driving cars will make errors. They will crash into people and kill a few people every now and then. And
still, it already has.
This already happens, and even if they get better, this will happen increasingly often. And those errors will be different from those that a human will have made, and that will distress people very much, even if they're safe or unbalanced. So, I mean, that would distress me very much. So I would hesitate to unhook the steering wheel.
Yeah. 5 years, I think, is very optimistic, especially because of what you say about.
But it's not unrealistic. But
from a technical point of view, I don't think so. But from a more societal kind of acceptance and legal point of view, it probably will not.
Yeah, the customer pull will not be enough.
But there will be a point, at least. If it's not 5, then 10, 15, 20, 30 years. Do you think there will be a point when we, sometimes people compare it to horses. We still can ride horses if we want to, for fun. But it's not for any kind of practical purposes. It's just for fun.
I understand there are more horses now than there used to be. But
oh, really?
but
but you don't use it for transportation purposes,
no,
at least.
Go around in circles.
Yeah. Do you think the same will occur with cars? So you can still drive cars for fun, but it won't really be used for transport.
I'm sure there will be a time pretty soon when personal transport will be solved entirely automatically. I don't know if it will be in the shape of today's cars, though. Okay. It might be different. I'm thinking about, public transport in various ways. I mean, already public transport in many places is autonomous. Right. Trams and metros are driverless. And I
think in Japan they more or less have that. Right?
Yeah, the Copenhagen metro is driverless.
Oh, really?
And so this will be increasingly, and that will drive acceptance for the other.
Right.
So if you have somewhat constrained transport modes that are entirely driverless, then people will be more willing to accept. I think that's the way to get there. But I wonder if they will look like today's cars, if they will have the same.
Probably not. That's a good point. So perhaps cars we will have for fun, to drive around the track for amusement purposes, but not really for.
And maybe there will be, situations where cars will be more useful. Say that you live in a countryside, and there might be situations in where automatic vehicles are less useful or more error prone.
What if we switch to programming? Now, we spoke about this briefly before, but if you take the same argument here and say that today we still have humans driving, programming and coding and building systems and software, but we can see already today that Copilot and other tools like that are taking over increasingly together with humans to build software. Now, if you just extrapolate that and think that this will continue at a potentially exponential rate, which it has in recent years at least, it's not unreasonable, right, to think that in the future it will be questionable if a human should even write a line of code. Would you agree?
Yes. Not to the very last statement. I mean, people will be writing lines of code, but
for fun, yeah.
But for fun, I mean, or on a very macro level, maybe some prototyping stuff where no code has been written for, no human foot has tread before, and no fingers have tapped the keyboard before. But bread and butter programming, yes, well, I remember doing stuff with Ruby on Rails once, and just starting up a project, and zap, you had 500 lines of code, and I was absolutely flabbergasted by how useful it was, how much that increased my productivity. And then I realized, thinking about it, that I've only ever written one C program in my life, and I kept modifying it for the new purposes. Just copied the file and kept doing it, kept adding to it. I'm not a C programmer, I was bad at it, but I think most people have the same experience. You just keep modifying what you've done before, and that is both a great productivity raiser and also a source of many bugs and errors. And I see no way I would ever feel bad about the fact that much of database programming or much of web programming will be automated. I don't feel sorry for the people who put out of that mindless drudgery and can spend their time doing more interesting things like playing chess. I'm sure much will just go away. We don't do assembler anymore, right? Because we have cool tools to build quick products anyway. So,
and humans are having a hard time understanding all the hardware. So having compilers that are actually using AI even to this day to build the machine code is already used. I personally love programming, so I'm a bit pessimistic and feel a bit sad about the future where we can't.
I like Sudoku and I like programming, so I wrote a Java program to solve Sudokus, and I never used it once it was finished. But that's the sort of level of things we will be doing. Yeah. I'm sure we will have the advent of code, the code calendar coming up even when we have automated program.
But I guess we will use text as the main thing to talk to systems in the future, or even the car, right? I mean, we will simply speak to the car to say, go from point A to B, and use language for that. And the same with the system, instead of reprogramming it, you simply talk to it and say, please fix that.
Yes, now do it, but for French.
Yes. Yeah. Are you excited about that future?
Oh yeah. Freeing up people's minds to think about more interesting things. That's a good thing.
Awesome. Then perhaps the last more philosophical topic. So we spoke a bit about the Skynet moment, a singularity, a potential where we have a self-improving system that can reprogram itself. And then we have a lot of people that are asking researchers in AI about when do they think AGI will happen, a point where sometimes we have systems that are not only better in a single task, but in basically all tasks that human can do. Do you have any thoughts about that? Do you have any prognosis for when AGI will happen?
Well, I don't know what AGI would be. I mean, intelligence itself is a difficult thing to talk about. We don't quite know what it is. I mean, we measure it in certain ways, and then we sort of decide to agree. And it encompasses a lot of things that we appreciate in other people if they're quick, think on their feet and so forth. But people who are very, very intelligent have very few friends because they're too good at chess and too bad at talking to people. And so I don't quite know what we would be measuring when we say AGI and what that even means. So here's my prediction. I think that we may well have AGI at some point in the future, maybe sooner than even I believe, but I don't think we'll notice when we have it because we don't know what it is. So we'll all of a sudden, a generation or so down the road, we'll look back and say, look, they didn't even notice when that happened.
Yeah. Agreed. It's a good point. And it's like boiling the frog kind of thing, right?
It's a boiling frog thing, only I think the frog won't die in the end.
True. Nice comment there. So you're not afraid of it, but if you were to still make some kind of estimate, are we speaking 5 years, 10 years, 20 years, 50 years, 100 years?
Whatever it is we're talking about, I'd say some of it is here now and some of it will be here in a decade or so, yeah. And then some of it won't be here for another 100 years but having a fully autonomous agent that behaves in ways which are...
But still, can't you see some kind of inflection points?
Well,
the point where...
I'm thinking about this thing. I was going to say behaves in ways indistinguishable from a human, but I don't know that that's what we're aiming for either. So I wouldn't know if we want to aim for human intelligence, whatever that is.
I mean, that's a really good point. I think, for one, humans are much more stupid than people think about.
Right, and there's interesting stuff written recently about how in the past decades or so, about how what the way we think is not the way we think, and so there's reason to think about maybe we should release ourselves from being neurophysiologically plausible and just make sure to get on with the task, whatever that is. But if we want to have, I do believe we very soon will see behavior from system sides that's very versatile and able to address a bunch of tasks that are difficult for people because people are absent-minded and need to sleep and catch their breath every now and then. And so they're tireless. They don't need lunch. They don't need sleep. So, I mean, rather like Google has revolutionized the libraries in a way, having a large-scale search engine that actually has a sense of quality has made a huge difference to us, all of us. And we never noticed when that happened, but all of a sudden we don't use our dictionaries anymore. They're just there on the shelf.
It's a superhuman service that basically can answer more or less any question already.
Right, and we don't claim it to be intelligent. It's just a tireless librarian, and not a very polite one. It'll just point you to the sources, but it does the job. And I think we'll have more of those coming along. And when we put them together with generative AI, we can get behavior that's really cool. And some people will be distressed by it, but I can't see why. Because but it's when we talk about intentionality where we get into interesting science fiction bits.
So still, to just comment on some points you made. For one, human level versus AGI, I think those are two different things, as you seem to agree with as well. And AGI is probably much more intelligent, of course, than humans are. And I would even say that it's kind of easy to imagine a system that is much more intelligent than the human brain is, given how horrible memory we do have, especially short-term memory and long-term as well. But I would even argue that the reasoning capabilities we have in thinking a number of steps ahead or whatnot and doing some kind of logical reasoning is very limited as well. And it's easy to imagine a system that can do much better than that. Mm-hmm. And
well, the argument from many cognitive scientists today is that our reasoning capability is not for reasoning, but for explaining to ourselves what we're doing. It's a post hoc model of post hoc simulation of what just happened. Yeah. And we already did the thing that we're thinking about doing. And
in Spotify, I can say did post hoc explanation of music recommendations. Not using the proper model, but actually finding a explanation afterwards.
A palatable explanation.
Yes. Which is not bad, but it's not really how it works.
We're not telling you we're giving you this because you have bad taste. We're telling you have excellent taste. Yeah. No, so there's a whole host of interesting differences between what we expect of AI and what we expect of people. And also we're moving the goalposts all the time. So
but on that specific point, don't you still see some kind of inflection point, some point where it will potentially be self-improving when, no human could ever improve the system better than it can do itself. And at that point, there is no reason for humans to be connected to it anymore because it can simply, fix cancer itself much faster than if humans were connected to it.
Right, but if it keeps on fixing cancer and such things, then I'll be happy to have it, chug along. And if it, the obvious dystopia you're aiming for here is that it decides it doesn't need people and it will just power us down in some way. And that, of course, is a distressing thought. But I'm hard put at seeing any path of the current development going even slightly in that direction. So I'm not sleepless for these things.
Agreed.
They make for fun movies, though.
They do. Yes, Jussi, what are the plans ahead for Silogen, and perhaps you personally? What's coming months now that you just started at Silo?
Well, just keeping up with what's happening is in my future. That'll be a more than full-time job, given the state of the momentum in the field. For Silogen, I would say we've touched upon several of these things in this conversation. They are about understanding the use cases. I mean, there are really cool foundation models out there, and I think those will change a lot in the coming years. But they're very far from useful products. And bridging that gap is where Silogen is.
Yeah, I'm looking forward to see what you will do there. I think it's
we'll come back.
Yeah, it's an ingenious move, and I'm sure you will do amazing things with a lot of user value coming soon.
Yes, well, it's based on the fact that there's a number of live projects already. It's not. Yeah, okay. It has Silo AI has strong foundations. It's
awesome. Anyone that you would recommend to come on this podcast? Someone that you would like for us to interrogate?
Oh wow, many names come to mind, but I think you should call up Anders Sandberg if you haven't yet.
Yes, that would be fun. I haven't thought about that, but that of course would be awesome. Do you know him personally, or?
Yes, yeah, I'm sure he shows up in Stockholm every now and then. So
that would be a fun discussion. Awesome. Jussi Karlgren, it's been a true pleasure to have you here, and I hope you can stay on for some after work discussions as well, which usually contain even more interesting topics and philosophical debates. So thank you very much for coming here today.
Thank you for having me. This was a great conversation. Let's keep it going.